Okay, hello and welcome to our CAN and automation webinar on the topic of CAN and cybersecurity for today, May 16th. Before I will start with the webinar, I want to make some housekeeping notes. I just want to remind everybody that this event is going to be recorded. So if you don't agree, do not switch on your video or whatsoever, and do not use any audio if you don't like to be recorded. If you have any questions, please postpone them after the presentation. You can ask your questions via audio if you want. Please keep in mind that audio will be recorded. And otherwise, you may also ask your questions in the chat so that I will read them and will try to answer them. The recording will then later on be maybe published at different occasions, like maybe our YouTube channel and so on. So thank you. To start with cybersecurity, I put in a definition, a short definition from Wikipedia. So what is cybersecurity about? And according to a definition of Wikipedia, it is about computer security, cybersecurity, or information technology security, for short IT security. And it is the protection of computer systems and networks from information disclosure, theft, or damage to their hardware, software, or electronic data, as well as from the disruption or misdirection of the services they provide. So we see the definition of Wikipedia is more a broad, I would say, IT definition. But it somehow can also be applied to embedded, or some call it OT networks, OT areas. Before I go a little bit further into the topic, who I am. My name is Thilo Schumann. I'm working for CAN and automation for over 20 years now, and I be an expert in multiple standardization groups within CIA as well as on international level. Over the years, I'm a little bit specialized in more the groundwork we used to use for safety, functional safety, as well as in security. So that's a short for myself. If you don't know who CIA is, CIA, or short version for CAN and automation. CAN and automation is the International Users and Manufacturers Group that was founded in 1992 to provide CAN-based technical product and marketing information. So basically to foster the image of CAN. Since the beginning of the 1990s, so it's now more than 30 years, we are trying to foster the image of CAN. We are heavily involved in further developments of the CAN technology itself. You may have heard about CAN-FD and maybe the upcoming CAN-XL. As a non-profit organization, CAN and automation is present in all around the world. Most of the members are based in Europe, and we are well over 700 members worldwide. As I said, CAN and automation was established and founded in 1992. Over the years, we were participating in different exhibitions and fairs. That's part of our marketing efforts to foster the image of CAN. We have published many different specifications, starting with our first, one of our first specifications, the A102 for the physical layer recommendations. We later on published our 200 series for the CAN application layer, which were further developed into what we know today as CAN Open. And I said we also try to bring people together, so we more or less regularly doing an international CAN conference where we try to bring the newest and best knowledge together to evolve on CAN technology. Our heart still is our specifications, which we publish, which are available for non-members and members, and any of our services are organized around those specifications. So we have many technical groups for different areas. We are having we are having groups for CAN Open, for CAN Open FD, the development of CAN Open based on CAN FD. We are having developments going on in the lower layers for CAN XL, for CAN FD Lite, for security on CAN XL, as well as for general security concerns. To stay up to date, I recommend any of our publications. So we're having our regular CAN newsletter magazine. You can also follow, and in addition, follow our CAN newsletter online. We provide as well different product guides, and we have the latest information on our website. So a short summary with all our member benefits. So that was a little bit of housekeeping and who we are, who I am. And I will now go into, some call it the state of the union, or what is the current state in cybersecurity, which apply also for CAN-based applications. So we have worldwide many different security standards. Security or cybersecurity is becoming in many areas a must these days, and it needs to be considered. But what does that mean? I said we have different, more or less, recognized specification standards around that. We have originally from the IT area, the ISO 27001, which have some general security techniques, requirements, and management, and so on. We have specifically developed from that in the automation industry, in industrial communication networks, the IEC series 62443, and in parallel in vehicle application and road vehicle applications, we have the 21434, which covers cybersecurity engineering. So that's for many somehow the start on why they need to consider cybersecurity. There is the need, of course, for people to consider security. I can bring all the examples where things have happened, but I don't want to go in those details. You can read in the news maybe sometimes more about that. So from the standardization point of view, let's have a short look on the general ideas we have in those international specifications. So if we look into the industrial field, we already mentioned 62443, then we see that the standard is more like a process standard, as a guideline. It doesn't doesn't define dedicated things someone has to do, but it is more a guideline of things we need to consider and we need to find answers for. So besides the general part one, which of course defines terminology, concepts, models, stuff like that, we have the dedicated things like how to establish an industrial automation and control system security program. We have definitions for the operating of the industrial automation control system, and maybe some specific security requirements. So that means we can sort out those specification series a little more in detail. If we see, okay, we have some general policies and procedures, we have a system level view, and we have a component level view. But it's not really defining any specific things, as I said. It is more on a guideline on things we need to follow. It's like in functional safety, where there is no specific safety definitions in functional safety, the same we have in cybersecurity. So if we then look more on the general principle, let's say it that way, the general principle of the 62443, then we see in general, there are only 5 steps to consider. We need to identify important assets we need to protect. We need to identify for each of those assets the different threat models. And then we can start to define protective measures. When we have those defined, of course, we go apply them, we operate with them. We then need to verify, of course, those protective measures. And then the important part here is, over the lifetime of the whole system, we always have to reiterate over those things. Or in IEC, the life cycle is that way. We first analyze or define our assets. We define the threat model, make the threat analysis. We try to define a secure design from that. We realize that we do code analysis, we do pen testing, we keep doing all those things of testing and hardening our system. And we go in operation, but it's not finished there. We have to go through the whole cycle until our system is decommissioned. And that means we in a constant process. And this constant process means a constant update and management system. So that's for industrial. What's about automotive? I mentioned already 21434. In general, if we look into the automotive standards, it's basically the same. It's an overall security mechanism and management process, and we have to look on those different things. So the question is, for security, also on CAN, we need to first identify our important assets. So what's the important asset? It's the software we run in our devices, in our system. And then we have to think about, we want to make an update of those software, of those firmware. We want to make it over the air, maybe over the internet, over the air, whatsoever. Like if I'm having a car, I may want to update the software running in my car. So we need to think about what can happen in the update process of the software. An important asset could be business-related data. So like we are collecting data in our car, like if I'm operating a taxi fleet, in each and every taxi car, there is business-related data that is well maybe transmitted into a cloud, so that it makes it much more easier for my business process, for my procurement and all those kind of things to work with that data. It's maybe running the system itself. Like if I'm having a train or a car, I need to consider that maybe someone is working with the data in an unintended way. And so operating the system in a way that I don't want to have. Or maybe it's theft of parts of the system, of the complete system. We have this, like, for example, if I'm having an electric bike parked at the street, someone may collect the battery from my electric bike. So we have a security requirement there. So the important asset here is maybe the battery or the bike. We have, like in industrial machines or in construction machines, we have expensive sensor units which are connected to my system, and which should only work in combination with that specific vehicle, so that it becomes worth it for the thieves to collect those devices. So I have different assets, and I have to think about first, what are my assets? Maybe it's also an asset could be also something like, I don't know, a virtual asset. So we learned that already, that some car manufacturers want to sell you a function as a service, like heating the seat. So it's a functionality that is being sold as a service. So so it should be only be activated when it's being paid for. So the asset is the functionality. And so while designing my device, designing my system, I need to first identify the assets, and then I need to define or to put it another way, I need to think, what type of system do I build? Do I build a closed system, which is where only a certain type of people really have access to it because I have a physical barrier? Or do I build an open system like my bike, which is parked on the street? Do I allow only local access? So I need to be physically there. There is no internet connection. There is no remote. Or do I allow remote connection? And all those kind of things need first to be considered. And then I can, from that on, I can start working on that and try to find solutions for my differences. Before I go a little bit more of details, I want to remind a great paper we had at the ICC in 2015. It was also published in the CAN newsletter 2017. It was called Plug and Secure Communication for CAN. And CAN has a very dedicated and unique feature. that works, of course, with classical CAN. We make use of that in the arbitration, which is the in-bit time response. And that allows us for a very unique functionality presented at that paper, which allows us to uniquely agree on a shared key on the network. It's a kind of Diffie-Hellman key exchange, but on the bit level. I don't want to go too much into the details of that, so I really want to recommend to read that paper. As I said, it's in the CAN newsletter of 2017. And you can also find that on our website for the International CAN Conference. So now I want to go into the details, into some of the details for CAN related security. So we normally have our different OC layers, or I like to refer that in the CAN reference model, in our CAN reference model. And there we have the CAN physical layer. So the question is, what can the transceiver can do? We have some solutions maybe in the data link layer. And everything above is somewhere in the application layer. Or we may have definitions in higher things, which are I like to call the device profile or application profile, which are not really covered in the OC layer. So what can we do, or what are the possibilities which exist today on the lower layers? First, we have there some transceivers which have implemented certain allow and deny listing. So that means I can put some piece of hardware in my design that tries to detect if there is a CAN message on the network that should not be there, because I'm the only one that is allowed to transmit that, or that should not be forwarded to my host. And so on the transceiver level, I have the possibility already to have a allow deny listing and to make security much more easier. And allow only certain data through into my controller's ends. So that makes it a little bit more harder to attack physically the network. I don't say it makes it impossible. I only want to say it makes it a little bit harder. Of course, this also has some kind of trade-off, because those allow lists, those deny lists needs to be managed in a certain way that is either fixed in, burned in the transceiver. But if it's fixed in, burned into the transceiver at production time, I cannot change that during runtime. So adding new functionality to my system is becoming harder, even if impossible. But if I make those lists manageable from the host controller, it's becoming a new way of an attack vector, maybe. Because someone on the host can also modify those lists to his liking. So, as I said, it is a first good approach. It is for certain applications a good solution, but maybe not for all. Another possibility would be fingerprinting. So if we look into the CAN newsletter of 2012 or at the 17th International CAN Conference, we had there a very good paper on signal fingerprinting. If we have our CAN network, we have those different nodes distributed over the network. Each node is transmitting its physical signal, and it is with that having a dedicated signature in terms of what are the voltages, what is the timing, and these kind of things. And if I'm at a dedicated position at another position in the network, I can monitor those on those levels and maybe detect if has something changed over time, or not over time, more if changed something from yesterday to today, which means someone may have added a new device which shouldn't be there, or someone have removed a device. So I can even implement monitoring, like intrusion detection. I wouldn't call that way, because intrusion detection is normally more associated with kind of software with more of high-level analysis, but that's more low-level analysis on the physical network, which where I can monitor and look for new unexpected devices or changes in the physical behavior. So someone has tampered with my physical network. So that's on the lower level. If we go a little bit up, we are currently working on CAN security, or short CANSEC, for the upcoming CAN XL specification. The general idea is I have my CAN network with different nodes, in this case, 4 nodes, A to D, and I can define that certain nodes are belonging to a certain, what we call secure zone. So they work together. Each node is because we are still on CAN, is broadcasting the information. And so that means we don't have a direct connection between 2 nodes with security, but one node is communicating its data like we used to use in CAN, so producing the data. Everybody can consume it. And we enrich the data with some possibilities to authenticate the data, and maybe also to encrypt the data, which means that only the nodes which know the decryption requirements, like the key mainly, is able to work with the data. And of course, if I need to set up a complex communication, as you see with the colors, it will become complex. Of course, like on the right side, you see we can also combine different secure zones. So it's not only that a number of nodes belong to one secure zone. We can also define a number of secure zones, and like in this case, define that one node maybe belongs to different secure zones. Of course, for each and every secure zone, we are using different key material. In general, the CANSEC then is, as you would assume, we are taking some bits from the CAN XL frame, which needs to be protected, which is, of course, the priority ID, the data length code, the service data unit type, the BCID, the address field, and so on. And we secure all this in common, and we enrich that with the corresponding signature data, which is, as you would expect, not a simple signature, just it's all the requirements we have from all the security protocols you basically know. So nothing very specific here. So that's the short version on CANSEC on the protocol level. Of course, we are still also working on the management, because we have different key materials. Keys needs to be updated so that we have We need a key update mechanisms to generate temporary keys, to distribute maybe those keys in a certain way. And that's normally considered as key management. And we are currently in the work of defining that. We have also some similarities in the works for CAN-FD and for classical CAN, what will be called the generic CAN security layer, a short impression on how that is being mapped to CAN-FD. But in general, you see the same thing. We are taking some data from the CAN frame, in this case, of course, from the CAN-FD frame, like basically the data, and we are enriching this with some additional secure data with a signature and additional information to secure the whole frame. So what you can expect. The challenge in CAN-FD, of course, is still we have 64 bytes, but it is somehow limited, and we need to think about how to reduce key size. So that's a topic on which is there are some ideas also written down, and we are currently in the discussion. And of course, the same mechanism may be also applied to classical CAN, where of course we need to reduce the signature even more. And because we only have 8 bytes of data available, and we want to make use of the whole 8 data bytes, but we have like in certain protocols, we don't use the whole CAN ID because we use only the 11-bit CAN ID. So we may be able to put the same signature information into the additional CAN ID parts. So we can map those. Of course, as you may know or understand, if we squeeze the data in security, it's becoming a little bit insecure. So the question is also, if we are going back to what I started in the beginning with, we need to identify our assets. We need to identify our threats. We, of course, part of the threat analysis is how much security do I need? And then I need to apply those different mechanisms. Of course, we have also a definition for the key management on how keys are refreshed, something we always have and need, of course. So that's currently in the works at CAN and automation. I said we also having some definitions on the higher levels, on device profile or application level. And here I want to mention maybe ISO 16844, the tachograph. You may have heard about it. That's the thing that isn't running in any commercial truck these days, because the driver needs to identify with its card, and everything when the driver is driving is getting recorded, like its speed, like the date and time he's driving, and so on, because it needs all those things needs to follow. Also here we have a security in place. There is a security from the speed sensor, which is typically placed in the gearbox, up to the electronic unit in the dashboard of the truck driver. We have there a secure CAN protocol. We have there a physically defined secured CAN connection. So if someone tampers with the CAN connection, we are losing the security. And the control unit will detect that. But, and the thing is, all the security or the key material in this case is held in RAM, for example. So if we are losing power, we are losing the secure connection. And the secure connection needs to be reestablished. And that needs to be done in certified service shops. So you see, it needs to be done in certified service shops. So that means, I just want to mention here, it's not only defining the security in terms of protocols, in terms of key management on the protocol level. You also have to think on how to set up the system. How is the general key management being done? Where is the secure place? Is there a secure place? So there still, just aside from all the protocol definitions, from all the things we can do on that, there are more general definitions we need to consider when we want to do security, cybersecurity. And one important part we also should mention is, how do we respond to problems like incident management? So if someone is reporting a problem with the system, we need to make it possible that people can report problems. We need to make it possible that those reported problems are being taken with care and not ignored, like in some cases. There are some general organizations. They are sometimes called certs that help me with them. Some companies have their own system set up, but that's another level which we need to consider in terms of cybersecurity. It's not only that the engineer puts something in a device or writes a software or some engineer connects some devices, choosing the right protocol or not. It is a process in the company that needs to be set up. And then, of course, I sometimes like to close with XKCD, because there's an XKCD for everything. I could have also taken a report from Ken Tyndall he just made recently published. We can make things secure, but think about, people don't take the front door. So we can apply lots of security, but the problems are in our backyard. So we need to really think about the complete system. And with that, I'd like to thank you. And if you have follow-up questions, please direct them to best way to service@canCIA.org. And we try to help you. And you are also happily invited to join as a member, and as a member to join our activities to standardize and to bring the technology forward. Thank you.